Yeah, hi, welcome everyone to this session on Technology Roadmap 2030 India context. Welcome to everyone. Today we have two power-packed keynote that we are going to listen to. I would like to welcome the first speaker, Dr. Bhaskar Ramamurthi, to deliver his first keynote. He is the director at IIT Madras and also the outgoing chairman of TSDSI. We welcome Dr. Bhaskar.
Good evening to everybody. Good evening from India. Maybe afternoon elsewhere. Good tidings wherever you are, whatever time zone. So thank you all for joining this technology deep dive conference and the first day's session on the technical roadmap. I'm sort of donning my hat as the outgoing chairperson of TSDSI. I handed over charge only this morning to the incoming chairperson. So this presentation tries to capture the way TSDSI members see the technology roadmap for themselves. I'm going to start with a very brief sort of flashback, figure out what we want to do. Basically, it has to be driven by members' interest and members' relevance of the activity to the members. And then we have done a fairly extensive exercise in figuring out what we're going to do over the next few years, 3-4 years at least, if not 10. 2030 looks very far away, but at least over the next few years. But some of the activities that I'm going to allude to fairly long-term and therefore are likely to go on substantively till 2030. So our roadmap is created by our members, updated every few years. There's a committee. In fact, Anindya, who's hosting this session, is actually the chair of the roadmap committee. And the topics identified reflect global relevance, but also national relevance. It's carried out broadly in 2 study groups in TSDSI. All the technical work is driven by our members on a volunteer basis, and therefore, automatically, they reflect their intrinsic interest and relevance to the members. Lots of ideas came from the members, and finally, there was sort of some work that was short-term, some medium, some long. We worked on cloud interoperability. We continue to work on that. It's a very important area for the country and for the world, but in the country, lots of data centers are being set up. We need applications. Entire, as we go forward, we expect even the virtualization of telecom network is so heavy now that we want everything to be portable, canisterized. And so this is a very important area for us. Public safety, PPDR is also very important. India doesn't have a very well-developed captive network for the disaster rescue forces or for the police. A lot of communications is done using the normal telecom networks, which are very vulnerable to disasters. So PPDR is an important area. The country has its own version of geolocation and navigation called NAVIC, and we wanted to have its support in all the devices. This is a very peculiar, one of the countries in the world where almost every subscriber has 2 SIMs on their phone with 2 subscriptions, and there are lots of issues associated with dual SIM operation that many operators are interested in. The country has a huge number of official languages, not to mention the ones that are not part of the constitution as officially recognized languages, and Indian language support, particularly for the new financial services and inclusion, all the things that matter for inclusion, is very important. Rural, 800 million people plus live pretty uniformly spread out around 90% of the landmass of 3 million square kilometers. You parachute yourself anywhere in the country and start walking within 2 kilometers, you'll come to a habitation. So there is this thing called low mobility large cell, which we got introduced into IMT 2020 as a requirement so that our rural areas can see proper coverage. This kind of coverage for rural areas was not there as part of the IMT requirements for any of the 2G, 3G, 4G earlier. In order to meet the low mobility large cell requirement or exceed its performance requirements so that it will work really well. Countries like India, TSDSI also worked on the IMT 2020 RIT, which really focuses on the best possible performance for the LMLC use case. There's also a lot of some interest in broadcast offload. If the unicast request and if the same content is to be available on broadcast, cricket matches come to mind. Can we offload some of the traffic to broadcast, particularly for rural applications? There are issues of call drops in India because of the huge subscriber density and congestion in the network. IoT and M2M are emerging applications. A lot of concern about security, about how the data can be secured, how the systems can be secured. Customers can actually have control over their subnetworks. There's a lot of interest in virtual RAN and cloud RAN. So all of these were the topics identified. And so the various things were done. Study reports are, of course, almost the first thing that happens in all of these. And some of them have gone on to standardization. As I said, there's a candidate technology from TSDSI for the IMT 2020, which is very, very overlaps very large percentage with the 3GPP RIT, but has some improved performance for LMLC. NAVIC support has been included in 3GPP in release 16. Layer 3 offload of unicast, that what I just talked about, convergence with broadcast at layer 3, not at layer 1, is being discussed in 3GPP and within TSDSI study groups. and IMT 2020 evaluation, and all the steps towards finalization of the standard. All of this we have been members have been working on. Cloud RAN and vRAN, I think there's a lot of interest in enhancements over the IP RAN cloud radio. There's quite a bit of interest in architecture of vRAN, particularly for the emerging E-band and V-band systems. And then the issue of where the layer 1 to 3 functionalities will go between the radio head end and the baseband unit. We've already standardized national standard for CIPRI back front haul, and so there's been work going on in this. Cloud interoperability, there's an organization like TSDSI called CCICI. We partner with them, and we're looking at use cases for smart city projects, gaps that are there vis-a-vis global standards, and trying to work out the draft specifications. Also trying to create an interop test bed so that you can have plug fest. Spectrum studies is very important. We work with many member organizations who have a great stake in this. Our space organization who operate our satellites, and the defense, the police, and so on. And as the spectrum gets more crowded and as we move into higher frequencies, there is already a great need for coexistence and sharing, and therefore enormous number of, there are lots of studies that have to be done for this. I'll come back to this later. Indian language support I already mentioned. We've been working on 12-bit encryption and support for Indian languages in financial transactions. There's some interest in information-centric networking. There's some reports that have been written. There have been workshops that have been held. Still work in progress. Dual SIM, as I said, people have two SIMs. So there are cases where the phone has single RF but dual SIM, and there are cases where there are dual RF and dual SIM, and there's interest in seeing how the applications can be managed, whether both can be operated at the same time or not. Typically today, the phone is used with one of the SIMs at a time. This is still work in progress, great interest to some of the service providers who are members. In fact, I can tell you don't have to go back. We ran into some basic problems because of dual SIM when the pandemic broke out, because under careful control with a lot of anonymization, proper anonymization, mobile trace data was being used to trace contacts, and we ran into this problem because everybody has got two SIMs. So they use them at different times. The regulator recognizes the two SIMs as two subscribers in every respect. There are lots of issues that have come out of this dual SIM, ubiquitous dual SIM use in the country. It started because people want to have two SIMs for coverage reasons or for other reasons. They start with one subscriber, they move on to another, but they wanted to retain the number towards dual SIM, and it raises a lot of challenges. 2020 onwards, we've done a great exercise now to figure out what the members want to do. Again, various things have emerged. You can see new things have emerged: 5G enablement, enhancements, fixing the gaps. There is a national digital communications policy of 2018, and we want to look again spectrum studies in that context, dynamic spectrum architecture, E-band, how to handle E-band, rural broadband. While LMLC is great, but how is the architecture going to be? How are you going to have multiple operators? What about OTT, and what about various services that the government needs to provide for financial inclusion, for education, and so many other things? How do we bundle everything together? How do we offer services from multiple service providers? So there's a lot of issues in the architecture. I think there's great interest now, increasing interest in virtualization, ORAN, and that combines with the cloud interoperability and cloud resource management for the radio now. As the IoT picks up, we want to look at smart IoT data pruning at the end nodes, because otherwise the network's getting clogged. And I'll give you some examples. Mobile, the nation is looking at a new mobile as a new data protection bill, both personal data and non-personal data. And most of the data in India comes from mobiles, because that's almost the only data connection that people have. So there's a lot of interest whether standards can play a role in increasing data protection and privacy and guaranteeing it, and so on. There's a lot of interest in the D2D, so device-to-device context of contact tracing, proximity detection, especially in the context of PPDR. Applications of 5G, autonomous vehicles is of great interest the world over, but the Indian context has some differences, and I'll talk about that. Rural broadband, community networks, financial networks, and applications for sectors like railways, police, and so on, which I alluded to earlier. Traditionally use their own captive networks, but what can they do going forward? Then we have beyond 5G, 5G plus, and 6G. And there's a lot of interest in AI, ML, haptics, the new sensors, new technologies that will increase the power of the applications. There's some interest in quantum key distribution for more secure applications. particularly in the financial space. And as I said, coexistence of satellite, terrestrial, and coexistence of other users, sectoral users and cellular. Next slide. So I'll just sort of, since this is now we are going into new areas, let me share my own thoughts now. These are not necessarily the thoughts of the members, thoughts as well as what I know from work that's already going on. Satellite terrestrial coexistence is becoming very important. Other administrations, for example, Japan are doing it. Japan is already using C-band both for satellite and 5G. But their experiences are not directly transferable. For one thing, our satellites are on the horizon because we are in the tropics. India has a huge population. There are millions, hundreds of millions of transmitters. So even on the uplink, which normally we would have, most of us would have thought is immune to interference from terrestrial communications, it turns out that when you have these zillions of handsets and the satellites at the horizon, it's really not true that the satellite doesn't know about us. The satellite does see a rise in the noise floor, and so the analysis done by countries which are more in temperate zones, where the satellite are much higher than the horizon, don't quite carry over. You have to redo many things. You have to be more careful. E-band studies, the bands will be the beams will be focused. The antennas are small. Frequency wavelengths are very small. They are going to be used for short haul, particularly because of our huge raindrops here during monsoonal rain. The issue is it going to be unlicensed? Is it going to be light licensing or normal type of licensing? Crisscrossing links are possible because of the beam focused beams. How do we do light licensing in this context? So a lot of interesting problems even for academic research. Next slide, please. Rural broadband architecture in the Indian context. I'm referring to a term here called BharatNet, which is actually the optical fiber that's being laid by the government under the universal service obligation, using funds that everybody, each subscriber here pays into the USO fund whenever they use their phone. This terminates in what are called panchayat villages, roughly a third of our villages, the bigger villages. You have to cover the neighboring 2 or 3 villages from there, and whether that's going to be done using a base station at the panchayat village, 4G or 5G base station, or whether we're going to actually have relays that are going to operate in the other villages. Are we going to have millimeter wave in-band backhaul to these relays, or are we going to have in-band backhaul in the lower bands, FR1? Are we going to try new ideas like flexible duplexing to improve spectral efficiency in that case? Lots of interesting questions again. We want to make sure that the rural users can have all the advantages of urban users, multiple service providers, OTT, all kinds of things. So how do we do that when there's a sort of a publicly owned fiber connectivity in between? Can we do Wi-Fi offload when the village? Indian villages are very dense, actually. People live together in clusters. Can we do Wi-Fi offload? Can we have village community networks? The Japanese are talking about so-called local 5G, mostly in their industrial context. But can those ideas be carried forward into villages here? Lots of interesting questions. Next. vRAN, as I already mentioned, is great. It's great interest. Anyway, there's a huge momentum in virtualization of the RAN, and the localized RAN clouds for clusters of sites are likely to come sooner than later. Co-located edge computing for applications. For example, the police use a lot of surveillance cameras. There's no need for all these feeds to go very far away. They can be localized clouds for them. Are clouds going to be captive or third party? How about the standards for the connectivity for the radio headends? Are you going to go ORAN? Cloud interoperability, I already mentioned, we're already working on this. All of these become very important in the context of vRAN. Next slide, please. Next slide, please. Yeah. V2X. Everybody's talking about V2X all over the world. Autonomous vehicles. The early application for this in India is likely to be in tractors, in farms. I don't have time to go into why this is so, but it's also being pursued in Japan. Because there is being pursued because simply they don't have enough farmers. And also it's very expensive to have a farmer driving a tractor. So there's also, in the Indian context, heterogeneous traffic on our roads. At least there are 6 different vehicles in 6 different speed brackets on our roads, and at least 4 or 5 or 6 different kinds of vehicles in terms of size. Mostly at best 2 lanes in each direction. A lot of weaving in and out unavoidably, and it drives everybody crazy, and therefore people make mistakes, people take risks. how can we use the technologies that are available in V2X with the low latency to actually reduce traffic accidents. I think that is going to be what is going to pave the way for autonomous vehicles. With the kind of traffic that we have and the number of accidents that we have per 1,000 million vehicles, I don't think we can have autonomous vehicles otherwise. Drones and UAVs are early days. Countries trying to adopt policy so that we can get in on this along with everybody else. Security, safety are important concerns. This is an area again where V2X technology can be important. So we have to probably look at how V2X can be used to drastically reduce accidents. And on highways, we can use platooning to improve safety primarily. Again, if vehicles are going a long distance, a few hundred kilometers together, all going from point A to point B, why not platoon them and give them an incentive to be part of a platoon? Next. Captive networks. The railways have had captive networks. Our defense establishments. I don't mean tactically. I mean their peacetime establishments and the police. All of them have captive networks, but it's becoming increasingly difficult for them to keep upgrading them to new technologies. Expense is very high. So can they use slices of the network that is also serving the public at large? Can they get sufficient security in this, sufficient resilience, service guarantees? What about the regulatory issues about spectrum and, can they use captive spectrum for this, for which they pay differently? There's so many things that come into play, but 5G network slicing certainly opens up all these issues. Next. Release 17 and beyond, this is more sort of continuing work. So the members are of great interest in further capacity enhancements, coverage enhancements, in-band full duplex, particularly flexible duplexing to begin with, where two users are transmitting up and down at the same time, particularly in a rural context. I mentioned this. Enhancements to IAB, support for in-building systems, and also for village in-band access and backhaul, particularly for village-level relays. Support for MBMS in 5G NR, and some options modes for deployment in standalone mode, which are particularly of great interest to Indian operators. And in the context of vRAN, splits between the radio unit and the data unit, different options. So these are things that are probably understandable to people who are in the 3GPP space. I don't want to get into them in detail, but this is something of great interest to members in TSDSI. Next. Probably my last slide, I think. Yeah. 6G, we are going to see haptics. We're just waiting for breakthrough in the haptic sensors. It's the next big sensor. Once it happens, it's going to descend on us at great speed. Touch, feel, texture, which we really can't do through phones right now. It will also have a great impact on AR, VR applications when it happens. There's probably going to be a lot of machine learning in the RAN, in physical, in all the layers, PHY layer, MAC layer, network layer optimization. This will be unknown to the users, but very great importance to the people who make these systems, who standardize these systems. And in the application layer also, in the service layer, ML as a service for personalized ML models for users and so on. So these are all going to be of great interest in 6G. Some of it, especially when you start doing it as a service, you'll need standards again. And sensors, when the new sensors come in, we know what happened when touch screens came and cameras came. A whole new generation of phones will come with new applications, and definitely standardization will play a big role. Next. I think that brings me to the end. I hope I have not taken too much time. Thank you very much. And if there are questions, I'll take them later. Thank you.
Thank you, Professor Bhaskar, for that thought-provoking and enlightening presentation. I think every time I hear you, I think we feel really energized. And I think some of the takeovers from the roadmap work that currently is being pursued will provoke some more discussions within the members. And so we can now go to the next keynote presentation, which is by Dr. Matti. And Dr. Matti is one of the world's top researchers. He's the academic professor, professor of communication engineering at the University of Oulu, and currently serving as the director for National 6G Flagship Program for 2018 to 2026. So without too much of wasting time, I'll hand it over to Dr. Matti. Dr. Matti, over to you.
Thank you very much. Good afternoon, everybody. It's a really great pleasure to be here. with you, sharing some of our thoughts on how we see 6G for years to come. And I want to emphasize that this is a research perspective. Of course, nobody yet knows what 6G will be from let's say ITU perspectives. ITU has very recently started a working group on starting to define IMT 2030 requirements, and that process will last at least a couple of years and 2 years, and before WRC meeting next time, I think the requirements have to be publicly spoken out. But until then, we researchers will have great fun in doing all kinds of interesting experiments and proposals on what 6G could entail. We are talking about, when we talk about 6G, applications and services that we will have in 2030 timeframe and beyond. And by then, the digital world will look very different. If you think about where the businesses are making revenue and where the big money is floating around, it's in data. Data is the next generation oil or gold, as they say it. So we have to focus on what do we do with data, how do we collect it, where do we process it, how do we make it to really useful, productive end user applications, whatever the end user is, and how we utilize the wireless connectivity in collecting the data efficiently, and so forth and so forth. So it's really data-centric picture for that era. Our flagship program is probably the first bigger 6G research program globally, and we started a couple of years ago. And it's 8-year program. For the first 2 years, now we are revising our research agenda for the next couple of years, but for the first 2 years, the 4 leading themes for research were, first of all, wireless connectivity, then devices and circuits, distributed computing, services and applications. Wireless connectivity we all are very much aware of, and for several years already, mobile broadband connectivity solutions have been really the key driver for that. And with 5G, these machine type communications, mission critical communications, and URLLC type of connectivity solutions have come into play and are setting new types of requirements, which is really interesting and exciting to look at. And it changes really the optimization game completely. Device and circuit technologies are changing because of the fact that we are moving to higher and higher frequency bands. With 5G, we were talking about millimeter waves. Now, with 6G research, we are talking about sub-terahertz or terahertz frequency bands. And at that high frequency bands, we have to start to look at completely new materials and circuit technologies in order to make hardware implementation somehow possible and financially viable. Distributed computing is really one of the key technologies, and it's happening already now. Edge intelligence is probably the biggest thing there. We are moving a lot of intelligence from centralized cloud to closer to users and end applications. And in that way, we can really shorten the latency, and we can improve security and isolate the local cloud to physically to places where we want to maintain critical data, and we don't want to distribute and disclose it to outside network. So edge intelligence is really one of the key things in improving user experience for years to come. The fourth one, services and applications. Haptics was already mentioned in the previous presentation, but there are many other interesting future directions that we can foresee, like holographic communications, and the role of AR, VR, XR devices is also interesting to look at. But more than that, more than technology perspectives, we are looking at really deeply overall value chains and ecosystems related to different vertical sectors. We have to understand far better, for example, what are the requirements in factory setting versus health systems in hospital environment, etc., etc. So there are so many different requirements, and we have to understand them thoroughly in order to try to optimize and try to develop better services for those new areas. Okay, I'll skip to that one. So there is some statistics of our first 2 years of operation. If you are interested in finding out what we have been doing lately, I can advise you to go to our website 6gchannel.com, which has lots of materials publicly available. We have published so far a dozen white papers on various aspects of 6G, which you can have a look at. And on the right-hand side, there is a schedule for our webinars where each of these white papers that were published this summer are disseminated publicly, so anybody can join and those discussions and challenge some of the key researchers on these various topics that we see are really important for 6G research currently. By the way, today we released the latest 6G Waves magazine, where, for example, you can find a nice overview of all of these white papers. So what are now the driving 6G research? Already with 5G, we saw that 5G key driver was really how can we improve productivity of various verticals? How can we make industry more productive? How can we improve logistics chains? How can we do this and that far better? So that was really the key driver for 5G development. And as we know, 5G is not going to solve, at least in the early phases of 5G, all those promises that they have laid down. So those need to be worked further. We still need to look at better and better solutions to technically enable vertical productivity improvements. There are several other technology enablers besides connectivity-related solutions like machine vision, AI, robotics, and so forth, which are really important and making this future vision possible. What makes 6G gadgets and systems 6G? What is different from 5G? So there are a lot of other things that need to be developed before we are there. So these are on the right-hand side, these are really the hard values that we engineers have been working on mainly. But a new dimension that industry has started to accept, at least in Europe broadly, that we have a bunch of societal challenges that the whole world is facing these days. Recently, this year, for example, this COVID pandemic, which is a good example of great challenge that we have to meet, and we can always think that can technology and wireless connectivity solutions be really helping to solve some of those problems and challenges. United Nations has already, a few years ago, they have published sustainability development goals, 17 of those, and if you look at every single one of those and give some thinking to those, you start to understand that different technological solutions, it can be from telecoms or can be from other sectors. Technology can be really in key role in getting to those targets. And we think that wireless connectivity solutions of various sorts and future digital applications enabled by wireless connectivity can be an essential role in every single one of these. So we really have to look at these softer values when we start to think about and define what are the targets for 6G? Why do we develop 6G technology after all these other technologies? And that's a new kind of thinking that we have been trying to introduce here. And so although we try to bring in a little bit human thinking to technology development, it can be really profitable business, depending how you see it. And business is not only business in traditional sense where we try to make great profits. From, let's say, a governmental perspective, we can talk about more on some money saving aspects, like if government has really excellent system for preventive healthcare system and proactively following our health in an efficient way and autonomous fashion, it can really create great savings to the whole society. And it's important as any money-making business as well. So anyways, we have to look at sustainability as well as technological issues in order to make future businesses. We think strongly that verticals will be much more strongly driving the technology development for the future. I will show you a little bit later one table which shows different technical requirements for typical service offering in some key vertical areas. We need to look at verticals also from other perspective. If you think about classic traditional mobile network operators, they are not able to handle all different critical and important verticals, at least early days of 5G. We need new service providers in order to speed up digitalization of societies in specialized areas, for example, agriculture or sustainable energy. I do doubt that network operators have the expertise on the whole value chain related to those areas. They can probably pick up some critical vertical areas and can bring in a lot of good solutions for those, but they cannot cover all important vertical areas. In Japan, they have really interesting vision for 2030. They talk about Society 5.0. Many of you probably are aware of this, but they also are very strongly introducing United Nations Sustainability Development Goals. And then they have drawn these different levels of circles where they have identified different stakeholders, different critical enabling technologies taking us there, and also different vertical sectors, application areas that can benefit from these technology developments. So this is really interesting. And at least we are paying a lot of attention to this Japanese discussion on Society 5.0. Regulation policies are really critical in enabling future developments. If you think about what is happening in radio technology wise, we are moving to higher frequencies. It means we are enabling larger and larger transmission rates and higher capacities in the systems because of increased bandwidth of the system. We are also making the cell size smaller and smaller, going to ultra small cells, and we are actually starting to build mobile network infrastructure very close to end users and end applications. So the question is, how should we build such a world? Are mobile network operators the only players in building this future necessary infrastructure, or would we need something else? And we want to say that yes, we need some other players as well, coming through different verticals, coming through different particular physical spaces and places. So the owner of certain space must have a say what type of specific service offerings they need to run their daily business smoothly. And they also probably must have a say that who have access to those services. Is it free of charge to use those services, or is there some tariffs for that, etc., etc. So we need new players, new type of thinking for it. The good old mobile network operators are definitely critical also in the future. We need them for various reasons. We need them for providing a lot broad area coverage solutions, and we need, if these new players are coming into play, we need them to collaborate very closely with large operators in order to provide a smooth overall service offerings. When we talk about 6G, and whenever we talk about the next generation, I think still, do we like it or not, but the mobile broadband is still driving the development. For 6G, we are talking about peak data rate of terabit per second level. We are talking about extremely reliable communications. We are talking about very low latency. Some people talk about zero latency. And we talk about global coverage. Anywhere, everywhere, people have to get connected to the network. So if you think about this as an optimization problem, these requirements are completely contradictory. You cannot meet all these requirements at once. So the critical question here is, can we even have one uniform system concept giving you all these solutions? And that is really one of the critical research questions that everybody is now looking at. or should we have, let's say, vertical specific requirements and vertical specific tailored solutions for these critical and really important vertical application areas? One thing that was missed so far from all generations was radio-based positioning solution. I'm not talking about GPS or satellite, but if we can embed positioning signaling to be part of this mobile cellular signaling, and we could start to think about extremely accurate indoor positioning and 3D imaging type of services for those special areas where we have implemented these future broadband radios. So, contradictory requirements start to require application-specific optimization. We cannot meet these requirements at the same time. Okay, what is happening here? One thing I would like to mention here, that when we prepared these white papers, we organized a series of 60 summits, and as an outcome, we published white papers within an international expert group. So these groups were open for anybody interested. The next 60 summit will be arranged in June in Porto, Portugal, in connection with EUCNC, which is European Commission funded annual event. Maybe I jump a little bit over here and go to this one. So this June we published 12 thematic white papers on these areas of importance that we thought will be important to look at and talk about in public on 6G research. So we have been trying to raise valid or justified research questions to 6G. We are not suggesting any solutions yet. We are just proposing interesting ideas for researchers. For the next few years, the whole research community is looking at 6G possibilities from various angles. And I would say that after 2-3 years, we start to have suggestions on system concepts or parts of system concepts, which will be critical for 6G. I would like to say now, bring an example of one of the white papers on validation and trials, where this group looked at different verticals shown on the left-hand side, and they have made, of course, strong assumptions about what type of applications are run in these verticals. Then they started to look at what are the minimum requirements for making those applications possible, and what are then the technical KPIs in order to make that vertical possible in the future. I'm not going to any of these details because I'm soon running out of time. But when you look at, just take a glance of this table, you realize that the requirements are really different. So if you try to develop one system concept satisfying all these requirements at once, it will be a compromise of various things, which cannot become a very efficient solution to anything. So it's a big compromise, not resulting in the type of system that we would really need. So we have to look at very carefully what different verticals need and try to think also technical solutions that would make those possible. Here's another glance of broadband connectivity challenges white paper, where different potential technologies making these foreseen KPI targets possible in the future. Really interesting and highly controversial issues as well, and good topics for any high quality academic research still. For example, we don't know yet, is terahertz communications going to be useful at all or not? We don't know what will be the cost of transceiver, or how energy efficient solutions those will make, or what will be the link range if we are able to mass produce those radio equipment. So a lot of interesting things, and this is really beautiful time for researchers to start to look at different aspects related to 6G. The last slide, what I think would be great potential, for example, for India. Remote area connectivity. So far, not a single mobile generation was interested in trying to solve affordable services at sufficient level. We are not talking about ultimately the best performing mobile broadband services, but sufficient services for local community to make their lives easier on daily basis. So there are, of course, some technical solutions that can make it possible. There are definitely financial challenges, but I think we also should take a look at different regulative aspects, how to make it possible. But more so, we have to emphasize cooperation of different stakeholders. Quite often, these remote areas are not profitable for commercial player, but are extremely critical for governmental player to make sure that everybody, all the citizens, have access to future digital services. This issue has been neglected for so long time, and now it would be the really high time to give enough pressure to take this topic to 2030 standardization processes and make this finally solved. Thank you.
Thanks a lot, Dr. Matti, for this great presentation. I think a lot of new things, new concepts, and of course, new way of thinking, Society 5.0, sustainable radio links, and getting super efficiency. So there are a few questions. I'm just thinking whether we can, carry them over to the next part in the keynote thing. I have made a note of them. There were 3 questions. So I think in the interest of time, we'll take it over to the next session. Okay, I think one of them is very simple. I think maybe we'll touch upon a few. So I think the first one is 5G aspirations are based on the 5G triangle, where there are 3 main objectives set by ITU. For 6G, is there any aspiration currently set by ITU?
Not yet. The process has been started, and the work is at very early stages still.
Okay, I think there is another question which asks, how do you see 6G haptics different from 5G haptics?
We have to first make 5G haptics reality, and then we will have to think about what needs to be improved further. But definitely, from technical perspectives, the latency has to go down, and reliability has to be at sufficient level if you think about, for example, medical type of applications on surgeries, etc. So we will have to see how 5G behaves, and then see.
Thank you, sir. And I think I will say this is the last question of this session. Since 5G promoted small cell deployment, do you see a similar trend for 6G success also? And do you think it will be effective for large cells too? I think you can.
So it's quite natural when we go to higher center frequencies. It means shorter cell range. So I'm a big believer of small cell technologies. Yes. But then the question that would 6G be effective for large cells too? I would say that, for example, in this remote area connectivity challenge, yes. But let's say in metropolitan areas, I think there's a lot of room for improving, for example, backhauling technologies at higher frequencies. But for large cells, higher frequencies are not very well suitable too. So we will have to see. Of course, 5G and 4G, even 4G is evolving all the time, and we will have to see that do we need large cell technologies, and what other development goals for those? What are really the gaps that we are trying to close? And I would like to emphasize that this remote area connectivity is one important gap that we need to close.
Thank you, Dr. Matti, with those answers. And I think in the interest of time, I would request my host to take us to the next program of the day, which is the panel discussion. Thank you, Professor Bhaskar, and thank you, Dr. Matti, for your great...
Thank you very much. Thank you for hosting us. Thank you.
Thank you so much, all. So I'm going to end the session now, and all the attendees, you'll be moving back to social launch, but I'm going to start the next session immediately. So all the speakers will be back on the stage. Thank you so much, and we are taking a pause on this session.